So my name is Cong, and I'm going to talk a little about of the fatigue analysis work at Joy Global using large amount of field string gauge data with ENCODE GlyphWorks. For those who are not familiar with what we are, so that's a introduction of our company. So Joy Global is a leading global supplier of advanced equipment systems and direct services for global mining industry. So we've been around for many years. I think we are approaching the 130th year anniversary this year, so almost there. So we have two divisions, the surface mining division and the underground mining divisions. I'm working for the surface mining division. So this picture shows our product here. Let me see if I can open this video. Yes. So that part belongs to the underground, and all those products belong to the surface mining division. So we have, so our surface mining division is the largest producer of electrical mining shovel, which is right here. So, and we have drills, drag lines, and the loaders. So our products have been used in copper mine, coal mine, iron mine, oil sand, gold, and other materials all over the world. We also provide logistic and life cycle management service support through a global network of Joy Global Service Centers. So my work focus on the shovel right here. So let me go back a page. So that's a picture of our mining shovels. It's a giant made of steels. So it weighs more than 3 million pounds. So and the height from the boom point to the ground is more than 60 feet. Also from there to the backs of machine, 60, 70 feet. So it's pretty big. And the payload, the maximum payload we can have is about 120 tons. So we are able to just load this truck right here, 400-ton trucks, just by 3 passes. So yeah. And those machines are expensive and available for, they're valuable tools for the customers, so they want to keep digging, just keep digging with no stop, so because that's the way they make money. And so most of the key structural components are designed for the infinite life. And also because we not own the machine, so when we want to do any field test, we have to have the permit from the customer to allow us to do the test. And all the components so big and the load was so high, so normally we cannot do that in the lab, so we have to do the test in the field. So that makes it very difficult to do the test. So here is some background for the string gauge test and the fatigue analysis at Joy Global. So in the past, we have been doing this string gauge test for more than 20 years. So we accumulate extensive experience on the string gauge test. We used both glue down gauges and weldable gauges, and we use uniaxial, just single gauge, and string gauge rosette, both. So, and we use the string gauge rosette mostly because in that way we can make sure we will be able to recover the principal stress information when we back to the office. Those tests, we call that a stage test. So normally it lasts between 20 minutes to 4 hours. And we have a test engineer sit right beside the operator, and we ask different operations from the operator just to follow the load case we designed. So that way it's quick and we got what we want for design, but there's some downside for that. First, we got an engineer on board. So the operator normally operate the machine very smoothly and perfectly, because they don't want to abuse the machine in front of the designer. So, and the, the test was short, so I mean hours maybe. So, and we missed those peak load event a lot. And also because they are short, so we are trying to predict the life maybe 10 years, 20 years, just based on that 20 minutes data. We didn't feel comfortable with that. So in the last couple of years, we kind of changed our string gauge test methodologies. We switched from the short-term test to long-term test. So normally the test lasts 2 months to 1 year. And so the engineer just installs the sensors on the machine, then turn on the system, then leave. So the system just run 24/7 without any interference with the production. So the operator sometimes even knows there's a test going on the machine. So so in that way we can make sure we pick up the real operation of the machine. So our designed load cases and something else, so everything we can pick up. The thing is, in that way we produce a lot of data. So for one channel of the string gauge data, just one day we have 43 million points. And for the current test, we generate about 7 GB data each day. So that's a big amount of data to process. The fatigue life calculation method we are using here. So first one, we follow that British standard 7608. So this standard defines different joint classification based on the principal stress direction and also the type of the weld. So, and also it gives S-M curves for each different classification. And the core of the fatigue analysis is, I didn't see. Okay, so it's a critical plan approaching method. So this picture right here shows a typical result, fatigue life calculation result from that method. So it calculates the stress. So it's a stress-based method. So it calculates the stress at different angles at one gauge location. So then accumulates the damage there. So this picture shows principal stress around 45 degrees here. So it's a uniaxial load case, but also this method can do biaxial or multi-axial. So just, if we have that case, there's another like flower petal right there. So this new test requires new fatigue analysis procedure. So we had a customized fatigue software. It was programmed in the mid of the 90s, I believe. So it's pretty slow because the IT technology was not as advanced as today. And also we got a couple of software packages to manually process the data. We had to review and validate the data in one software and switch to another software to do the peak value and the rainflow counting for fatigue life calculation. So that introduced, first that's time consuming, and also it introduced some operator errors. So sometimes you can just pick up wrong channels by mistake, and also maybe you forget to set a thread hole there. So a lot of operator errors. And also we don't have a result realization from the server. This picture shows here, we not only record the string gauge data, which in yellow here, but also we record that machine functional data right here. So that's like some motor. I don't know if you can see that here. So the right line presents motor speed, and the line here defines the status of the machine. So is that digging or swing or dump, all defined by this line. So by looking back in here and time sync those signals, we know at one moment of time what the machine was doing there. So this information is used to reduce the data set for our fatigue life analysis. So now I need a automated process to integrate data process, strain gauge analysis, and fatigue life analysis altogether. So that means when the data come in, I can just throw the strain gauge data into this software, and I can have a reliable fatigue life calculation at the end of the day. So I don't have to, so we can eliminate or minimize the manual operation here. So so big set of data. We have about a half-year test versus 1 day in the past. And we need a fast, accurate fatigue life calculation solver here. And to do all, because we put down both uniaxial gauges and strain gauge rosette, so we need different methods to analyze them. So, and also at different locations, we got different classification, joint classification or weld classification, material parameters, so that's SN curves, and also this KF factor, surface finishing, and also the plate thickness. I didn't mention here, but that play a very important role here because normally we use the plate between ½ inch and 4 inches. So the thickness is, we need, is important here. As I said, integration of basic data processing, and also we need a system is easy to be customized and expanded. So later on we can put more and more modules in there. We can expand that. Good technical support, so when we have some technical difficulties, we know who we can talk to, and we can make sure we get the support from them. So I think HBM-nCode is doing a very good job on that. And the legacy data, because we get our legacy data there, so we, in case, and that did happen, we want to look back into those data and read those data out and do the analysis. So that's the requirement for the new procedure. That's a brief workflow here. So first, data in, then the data needs to be validated. So if we found abnormal signals in there like peaks or drift, so we put then we call this data cleanup function to clean up the data. So I'm working with our program on that currently. And if it's passed, so the data will go to the next functionality, so that's data reduction. So I'm talking two kinds of data reduction here. So first, I just mentioned we got those machine functional data, so we can time sync that data with strain gauge data. So I can just pick, let's say, digging data, just filter out those data for propelling or machine idling or waiting. So the second data reduction we are use is the peak value. So we use peak value to reduce the data, and that must be done if we have a strain gauge rosette. That has to be done. 3 channels at the same time and in phase. Then we have this strain gauge analysis module. So we can have the information of principal stress and also both the stress range and the stress directions. So we can take a look there to make sure those make sense for us. So otherwise we have to go back to the raw data because it did happen with, those channels got switched because in the field, so there's so many channels, so many labels, so it could be messed up. So it did happen. The last step is fatigue life calculation. So here, all those information, all those parameters is input there. So couple of years ago, so we evaluate some fatigue softwares in the market, and we decided to go with ENCODE software because when we do the benchmark process, we found ENCODE gave us very close life prediction with our previous software, but it's a lot faster. So this screenshot right here shows just the data separation workspace. So there's another 2 workspaces behind it. So one for the weldment fatigue analysis, another one for the plant material fatigue analysis. So this workspace here just separate data and pass the meaningful data to those 2 workspaces. So as we see here, so all those channels of strain gauge data have been named very carefully. So ENCODE can recognize them as different channels just inside one big test. So every day I just grab those data and throw in there, and ENCODE can recognize them. So multi-strain gauge analysis. And here we got a Excel glyph here. So it read in a spreadsheet with all those analysis parameters here. So we can define what kind of joint classification it is and what the SM curve we need to use and how, what's the thickness at this location. So everything like that in here. And also when we do the strain gauge analysis, we read in the strain gauge definition through a XML file. So it's not shown here, but we do need that for the strain gauge analysis. So the integrated function modules here, so as I talked, so we can view the data and found the abnormal signals, do cleanup, filtering with file reduction, and peak valley, rainflow countings, and so critical plan approach algorithm also built in here. So those 2 pictures just show the plot. So this one, I believe that's rainflow counting plot. And this one shows the principal stress direction right here. So we can see we can tell that's a uni-axial load case. So some advanced ENCODE programming involved here. So metadata, superglyphs, just to repeat that process for each angles and each gauge. So the benefits is pretty obviously. First, we eliminate the manual operation from this procedure. So that means we don't have those operator errors anymore. So, and also it's constant workflow, therefore, so we got constant live result because all those parameters have been predefined, so you don't need to do anything to change that. Compared to the result from the previous solver we have, so it's pretty accurate. The difference less than 2%. So the time is reduced dramatically. So I think because we integrate everything all together, we now have just one software package. And also that the thanks should be go to the fast ENCODE fatigue solver. For our first long-term test, I hired an intern to help me. So we got 2 engineers 5 desktop computers, and we did the analysis for 5-6 months to finish that test. And from the November of last year, I've been processed 1 terabyte data, just myself and 1 computer. So we are able to do that. So the process about 15 times faster. And because we reduce the time, so we also reduce the cost. So engineering time and also the hardware and the software involved in the test. So now we can, purchase less hardware and maybe less tokens from ENCODE. I don't know. So another big benefit is in that way, because we can get the result pretty fast. So we can improving the new product development by using the string gauge data to optimize machine controls and to improve the machine performance. So at the moment we're doing this current test, we were able to help them to break their daily productivity twice since the end of last year. So that means in 1 day the machine can move more materials every day without putting more damage to the machine. So it's pretty significant. And also we can respond to the field request quickly. As I said, we have different methods, fatigue analysis method used in this software package, so that means flexibility of analysis. And the last one is easy to program, because GlyphWorks, you got those functionality already defined, so just drag and put them all together. So our engineers can focus on the meaningful data, the engineering meaning of the data, not the programming. Okay, so that's all I have, and yeah, that's our goal. That's the goal of our Joy Global company. So solving mining's toughest challenges through world-class products and direct services. Thank you.